Hello guys, how are you doing? Today we are going to learn about the Vram. And first of all, before we dip into the understanding what is Vram, we need to know the definition of a Vram. A Vram is what's called video random access memory. So in short term, this is the temporary memory for the GPU. So this one is a temporary workspace for what? For the GPU. So every GPU, in case we have a GPU, this is a GPU chipset, for example. So this is a GPU chipset here. Then each CPU is GPU. So this is a GPU. Each GPU has what's called the VRAMs. The VRAMs are chipsets which are this way. They're around that. They are placed around the. So this is a GPU. They are placed around the GPU. So these are what's called the VRAM. So this is VRAM 1. This is VRAM 2. And normally you find a VRAM 1 at this side of the motherboard, VRAM 2 the other side, VRAM 3 this side, VRAM with the alternate. So you have VRAM 1 at this side, 2 the other side, 3 this side, 4 the other side, 5 this side, 5 6 the other side. So that's what's called the VRAM. So how does this VRAM works? So we need to understand how the VRAM works. So the first thing, we have what's called the CPU. We have what's called the CPU. The CPU is the central processing unit of a motherboard. So this is the brain of a motherboard. So the CPU sends the necessary logic information or commands into where? Into the GPU. So it sends some information to the GPU, whereby the GPU processes those information and stores them in form of textures, geometry, or what? Or shaders. So and stores them where? At the VRAM. So and stores them at the VRAM. So once the information is ready, once it stores them there, as it continue processing them. When it is ready, it is now sent into where? Into the display. So it's now sent into the display or into the screen. So all this information which has been processed by the GPU are temporarily stored at the VRAM. So the VRAM acts like a, so let's call this one temporary workspace. Why do you call it temporary workspace? Because those informations are stored here for just a few moments before it is sent into the display. So this one processes the information which are sent from the, so processes from the information, so process the info from the CPU, and this one renders or gives the command, renders the info or the data into where? Into the GPU. So that is what exactly what happens. So you have the CPU, you have the GPU, the VRAM, and the display. All those components works together. So in short term, we have the CPU. So the CPU sends the returning instructions, that is commands, came logic or data into the GPU, whereby the GPU at this moment processes those informations and loads the necessary textures, shaders, geometry, frame buffers into the VRAM. Once these are the VRAM, this VRAM acts like a high-speed workspace, and it is temporarily holding those data which has been processed by the GPU before it is sent it where? Before it is sent. Actually, it's just holding them for a rapid access. In case the GPU needs some alter data, it takes them from the VRAM. So once the GPU finishes rendering those informations, then you will have a final frame, and now that final frame is sent into the display. So these two must work together. So in case you have an issue with your VRAM, probably your GPU will fail to work. Why? Because it doesn't have the what? It doesn't have the memory. So some other laptops, you might find that some other laptops have the doesn't have the GPU, that is dedicated GPU, but they have integrated GPU. Integrated GPU, because they don't have the VRAM in form of a which are dedicated for the GPU, they will use what? They will use what's called the laptop RAM, the normal RAM sticks, the normal RAM for the CPU. And that one now you find you will have poor quality imaging, right? Yes. So you can go back a little bit. Maybe let me show you. Let me show you some few example in actual motherboard. So here with me, I have a certain motherboard which have the GPU. So let's have a look at this motherboard. So this is the motherboard. This motherboard has the GPU. So this is the GPU for this motherboard. You can see. Then here, this is the socket for the CPU. So already I have removed the CPU. So there was supposed to be a CPU chipset here, but I have removed because it is the removable one. Then here you have the graphics. So the CPU sends or renders them information or commands or data into the GPU, whereby the GPU receives those data and stores them temporarily at the VRAM. VRAMs are these chipsets. You can see these ICs here. This is one, this is two. So in fact, this IC, they have been labeled. They are labeled. As you can see here, this one is labeled VRAM. It is labeled VRAM. So I don't know whether you can see it clearly. Sorry for that, guys. So I don't know whether you can see it clearly. So here it is okay. Anyway, even if you can't see, I'm just explaining to you. So you have VRAM 1. This one is read and VRAM 1. This one is VRAM 3. So someone is asking, why am I not seeing VRAM 2? The VRAM 2 is in the other side of the motherboard, at this side. So you have VRAM 2, then VRAM 3 at the other side. You come back here, VRAM 4, VRAM 5 the other side, VRAM. This is VRAM 6, VRAM 7 the other side. This is VRAM 7, VRAM 8. So you can see. So this laptop has a total of 8 VRAM chips. So now, once those information are stored temporarily here, the GPU continues processing those data until it is finished, or in case it needs some other information, it just collects them from where? From the VRAM. Once those information are ready, it's now sent by the GPU. So the GPU is what sends the info into the screen. So once they are ready, they are sent through the GPU into the screen. So at the end of the screen, we will have the actual imaging, which are very clear and what enough a very standard geometry, right? Yes. So let me give you some other examples. I don't have the actual motherboard here, but I can show you in form of a. So I think I have one here online. So let me just show you. However, I will not be able to navigate through the image, but I will just explain to you verbally. So here you can see this motherboard. Sorry. So you can see this motherboard. This motherboard, that squared chipset. You can see there are two main chipset there. You have another one which is rectangular in shape, and then you have another one which is squared. That squared one is the GPU. So that GPU, as you can see, there are some chips around it. You have 4 chips at the top, then at the left you have 2. So you have 2 top, 2 left. Those are a total of 4. So meaning we have other 4 behind that motherboard. So those are the VRAM, which have the information for the it has the information for the GPU. Here is another example. Here is another example here. So This example, you can see this one still. We have also two chipsets. We have that rectangular one, and then you have what? That squared one. That squared one is the GPU, and you can see at your left side you have one chipset, and then there's a space there for another chip. That means there was another chip. There was another chip there. That was another VRAM which was removed, or intentionally there was not there. So maybe there's reduced VRAM. Then you have at your bottom side, you'll have what? Other two. So meaning you have the rest at the back of that motherboard. So guys, as you can see, all the GPUs have different what? Have the VRAMs. So they must have those VRAMs because those are the what? So those are the memories for the GPU. So meaning each GPU needs to have what? The VRAM for it to operate. Then if I can add on the explanation for that, you find that so this GPU is what's called dedicated GPU. This is a dedicated GPU. It is normally written small d GPU because this GPU is specifically dedicated to do the work of clarity of imaging, to do the imaging. Then we will have another GPU called integrated GPU. So in short, we have two types of GPUs. We have dedicated one and integrated GPU. Integrated GPU, it is written small I, then GPU. So this one is the GPU which is integrated inside the processor. So this integrated GPU, it is integrated inside the processor. So that GPU now will have a processor. So this is the processor. This is the buffered generation processor. Then you will have a processor itself here. Then you will have what? The south bridge at this side. So integrated, it is integrated inside this chipset. So this is the main chipset for the CPU. So inside here, we will have what? Integrated GPU. So that GPU now, instead of having the dedicated VRAMs, so these are dedicated VRAMs. So these are dedicated VRAMs. So these ones, they will use the normal RAM for the laptop. So here you will have the RAM slot or the RAM stick here. So this integrated, they will be using now this RAM stick. So this one is RAM stick. So instead of VRAM, they'll be using what? The RAM stick. For example, this one. You can see this one. So in case for this motherboard, in case there was no dedicated graphics, so we will have what? The CPU which just integrated graphics inside. So that integrated graphics, they will be using now the RAM stick which is inserted here at the RAM slot. And now you will find the performance is a bit lower and a bit poorer. You cannot compare the imaging of this one. So this one is less clear. Alright? Yes, because this one is integrated GPU. This one, you will have more clear imaging. You will have more clear images. Why? Because this GPU is specifically dedicated for enhancing the clarity of images. Right? Yes. So I believe so far at least you've learned something. That is now how the VRAM and the what? VRAM and the GPU and what? And CPU integrates. So this is the integration between the CPU, the GPU, and the VRAM. So I believe now you have a knowledge how the VRAM works and how it does their work inside the laptop motherboard. And now you know you have two types of the GPUs, that is integrated GPU and dedicated GPU. Dedicated GPU specifically dedicated for that work of image clarification or imagery. Then you have integrated, which is integrated inside the CPU, and their work still is for imagery. However, there's less performance as compared to the dedicated GPU, right? Yes. So in our next video, I'll be going to explain to you what are the different types of the VRAMs, because we have different types of them, and then different storage capacities. They also have different storage capacities. They're not the same. They vary because we have the gaming laptops, we have uh, the machines which are specifically used by the professions for their clear imaging and whatever. Then we have other normal laptops which have the VRAMs only for image clarities, right? Yes. So guys, thank you so much. Thank you so much for being patient, and see you in the next video. Please like, subscribe to this channel, and share with your friends. Goodbye.